my previous two video recorded discussions, you gained ideas about uniformly accelerated motion, horizontally, and vertically. Those are essential concepts that will enable us to understand the topic for today. That is why, for today, our topic is projectile motion. To give you a heads up, the discussion for this topic has two parts. First, our attention is on horizontally launched projectiles, and the second part is on projectiles at an angle. Here are the learning objectives. Describe projectile motion launched horizontally, qualitatively. And solve problems related to projectile motion launched horizontally. As mentioned last time, a projectile is an object upon which gravity is the only force acting on it. An object dropped from rest is a projectile, which is this. An object that is thrown vertically upward is also a projectile. And an object which is thrown upward at an angle to the horizontal is also a projectile. Remember that the influence of air resistance is negligible or neglected for all of the stated examples. Thus, a projectile is any object projected or dropped that continues in motion by its inertia. Inertia means resistance to change in its state of motion and is influenced only by the downward force of gravity. If other forces affect the object, then this will not be considered a projectile anymore. Let us use the definition provided earlier to understand horizontally launched projectiles. Now, let's have a scenario here. Consider a cannonball shot horizontally from a very high cliff at a high speed. So, let's imagine that gravity is switched off. Walang gravity in this particular scenario. Questions are, what would the motion of such a cannonball be like? And how could its motion be described? So, according to the first law of motion, which is the law of inertia, a body at rest will remain at rest, and a body in motion will remain in its motion unless acted upon by an unbalanced force. So using that, the cannonball would continue in its motion in a straight line at a constant speed, if not acted upon by an unbalanced force. So this path is what we call free gravity path. Or this is the horizontal path. Now again, pag walang gravity, the motion of the cannonball will continue because there is no force that actually hinder the motion of the cannonball. Now let's have another scenario. Same pa rin naman, but this time we will switch on the gravity. So again, in the absence of gravity, an object in motion will continue in motion with the same speed and in the same direction. This is for this particular scenario. Now, going back to what I mentioned earlier, the second scenario where gravity is switched on. Questions are, what effect will it have upon the motion of the cannonball when there is gravity? Will gravity affect the cannonball's horizontal motion? Will the cannonball travel a greater or shorter horizontal distance due to the influence of gravity? So those are the questions that we're trying to answer here for this particular scenario? So the answer to all of those questions is no. Now, gravity will act downward upon the cannonball to affect its vertical motion. Okay? So gravity causes a vertical acceleration. The ball will drop, as you've noticed here. So the ball will drop vertically below its otherwise straight line. Okay? Inertial path. Gravity is the downward force upon a projectile that influences its vertical motion and causes the parabolic trajectory that is characteristic of projectiles. This is now your parabolic path. Okay, in reality, when gravity is switched on, so the motion of the cannonball will be like this. So it creates a parabolic path. So this is one of the characteristics observed for a projectile motion. Kapag walang gravity present in the area, automatically it will move in a straight line motion. Okay, following the free gravity path or the horizontal path. But since gravity is switched on, it will act on the cannonball. So alam naman natin from the previous discussion that it will create a downward motion. Since the cannonball is projected horizontally, it creates a parabolic path. So with gravity, a projectile will fall below its inertial path. This is the inertial path. Okay, gravity acts downward to cause a downward acceleration. There are no horizontal forces needed to maintain the horizontal motion. So putting all together, so this is now what happens to your cannonball when we launch it horizontally. So this is the gravity-free path or the free gravity path or the horizontal path. This is the vertical path. So if gravity is switched on, so idea natin that it will move downward. But since it was projected horizontally, it creates a projectile motion, no? It follows a parabolic path. Now, in this case, no horizontal force to maintain the path of the cannonball in free gravity path, okay, or in your gravity-free path. Only vertical force present, which is your gravity, that creates a parabolic path. So gravity is the one that creates a parabolic path. The reason why it creates a parabolic path. Now, looking to the horizontal motion and the vertical motion of horizontally launched projectile. So for horizontal motion, forces acting on the object, if present, in what direction? For horizontal motion, no. Okay, that is why it moves in straight manner. Okay, if we're going back to the free gravity path or the horizontal path. Now for vertical motion, yes, because gravity is there. That is the force acting on the object, and that is why it moves in downward motion. Okay, so now for acceleration, present or not. For horizontal, no. Okay, kaya the velocity of the horizontal motion, the velocity of the cannonball remains the same. Okay, kaya constant yan. Okay, now for the vertical, yes. Okay, kasi the force that acts on it is the gravity. So gravity maintains or allows object to accelerate. Yun naman lagi ang purpose ni force. Okay, so yes, the direction is downward and the gravity is 9.8 meter per second squared. Downward ang kanyang direction. And the velocity of it changes per 9.8 meter per second squared. 9.8 meter per second each second. Okay, so that's how it changes per time. Okay, in terms of its velocity. So if we're going to look on this using those concepts that I presented earlier, yung sa table. So for the horizontal path, constant lang ang ating velocity. It never changed. Okay, as you can notice here. Okay, and we were using here the definition provided earlier. Kasi there's no gravity that allows the motion of the object in horizontal path to accelerate. Kaya pare-parehas yan na 20 meter per second. Now for the vertical motion, okay, the downward arrows, you would see that there is an increase in the velocity, which is 9.8 meter per second ang tinataas, right? That is due to the force, which is gravity, and that force accelerates the motion of the object. Okay? So in this case, we have to look on the horizontal motion and the vertical motion. So the horizontal velocity remains constant during the course of the trajectory, and the vertical velocity changes by 9.8 meter per second squared. That is the effect of gravity on the motion of the object. Okay, now to describe the motion of the objects horizontally and vertically in a projectile motion launched horizontally, we have to use equations para we can further understand the motion quantitatively. Kanina kasi qualitatively lang tayo. Okay? So here are the equations. For vertical distance, you can use this equation. You would notice that there are letters, no? For horizontal distance, there are also letters na bago sa atin. So the y and the x will lead you to the horizontal and the vertical component of the moving object pag pinag-uusapan natin si projectile. Okay? Basta y, yan yung downward. Okay? Or upward. X, yan yung for the horizontal motion. Okay? So same lang to sa mga equations na nagamit natin for UAM, but there's an addition lang for the vertical component and the horizontal component. These are letters X and Y. Okay? So for vertical speed, you can use this equation. Horizontal speed kasi uniform yan dahil we're talking about horizontally launched. As mentioned earlier, uniform ang velocity niya. Okay, now for time of flight, you can use this equation, but actually you can manipulate this one in order for you to get the value of t or this one. Okay, depending on the given. Yun naman ang sinasabi ni Sir even before pa. But this equation for the time of flight, equal yung value ng t ng time of flight for both of your vertical and horizontal motion. Okay? So kahit di yan ty or t sub x, equal pa rin yan sa isa't isa. Okay? So you can use this if you want to get the time, the value of time. Now, let's answer some of the given sample problems, and let's try to use these equations para mas maunawaan natin ang projectiles launched horizontally. So for sample problem number 1, a soccer ball is kicked horizontally off a 22.0 meters high hill and lands a distance of 35.0 meters from the edge of the hill. Determine the initial horizontal velocity of the soccer ball. So, gagamitin pa rin natin yung Gressa method to solve it properly, as well as we're going to illustrate the problem para we can further visualize it. So, may soccer ball na kinik horizontally off a 22 high hill. So, let's imagine this is the hill. Okay, so this is the person who kicked the soccer ball. And it falls, right? The ball was kicked horizontally. Kaya yung motion niya papunta dito. Okay? So, this is 22.0 meters high hill. Now, and lands a distance. So, bumaba yung bola here. Let's say here. And the distance from that, the ball, no, from the edge of the hill is 35.0 meters. That's the distance, okay? Now, determine the initial horizontal velocity of the soccer ball. Okay, now, for the given, para masagot natin tong required, okay, we are asked to compute for the initial horizontal velocity. So, that is V sub Ix. Bakit V sub Ix? Kasi horizontal sub X. Initial V sub I. Yun naman yun. Because we're referring to velocity. Okay? So, for the given, this is how you do it. Identify the X component as well as the Y component. Yun ang gagawin natin kasi we have to look on vertical motion as well as horizontal motion. So, for horizontal, X yung ginagamit natin. Okay? So, based on the given, meron tayong V sub X. Distance in horizontal motion, yan yung 35.0 meters natin. What else? Okay, since walang acceleration for horizontal component, A sub X natin is 0 meter per second square. Pero lagi natin ini-include yun. Okay? Now, for the Y component, meron tayong distance, no? Yung hill, gaano kataas yan. So, D sub Y natin yan, we will put it as negative 22.0 meters. Kasi nga, we're after with the direction. Okay? Yun. Okay? So, downward yung from this part going down. Yun naman yun. Okay? Negative 22.0 meters. Na force, okay, na acceleration that allows to have acceleration, yung A sub Y natin, negative 9.8 meter per second squared. Wala siya sa given, pero kailangan natin ilagay kasi nga we are describing the Y component. Okay? And ang V sub Y natin, dahil initial to, for the horizontal, di ba lagi naman natin sinasabi na wala. 0 yun. 0 meter per second. Okay? Yan yung mga natutunan natin from our previous discussions na UAM. So, initial velocity, dahil pababa ito. Okay? So, for the vertical component, 0 meter per second. Yun naman sinasabi ni Sir, pag pababa, 0 lagi ang initial nun. Pero pag pataas yung bato sa object, may initial velocity. So, these are the given. Okay? So, again, you have to look on the X component and the Y component. So, this is the required initial horizontal velocity. So, for our equation, so kung babalikan natin ito, kung titingnan natin, we are after with the V sub Ix. So, kung titingnan nyo, ito yung kailangan natin gamiting equation. Bakit? We're after with V sub Ix. So, we're going to manipulate it later on. Okay? But before that, since we're after with the time, no? Dahil may variable t here, t sub x, kunin natin yung value ng t. Okay? O, susulat lang ni Sir yung equations na gagamitin natin. So, for this one, in order for us to solve this, d sub x is equal to v sub ix t sub x. Okay? So, kung titingnan nyo, wala tayong given ni t ng time. Kaya, computein muna natin si time para maka-move forward tayo sa paggamit nitong equation na to. So, time of light, ito yung equation na yon. Okay? Di man yan t sub x, di man yan t sub y. Sabi ko kanina, time of light is equal to both horizontal and vertical component. Okay? So, gagamitin natin yung equation na yun. So, t is equal to square root of 2d sub y over the gravity. Okay, meron tayong mga given yan, kaya hindi tayo mababahala to further move on. So, t is equal to square root of 2 multiply 2 d sub y natin na negative 22.0 meters divide by the gravity, negative 9.8 meter per second square. Okay? So, when we multiply this one, it give us a value of t is equal to square root of a negative 44.0 meters. Okay? Divide by negative 9.8 meter per second squared. Cancel similar units. The value of t natin, divide lang natin to. That gives you a positive value. So that is square root of 4.48979. Okay, 592 seconds squared. Hindi natin siya i-round off to 2 decimal places kasi hindi naman yan yung final answer pa. Okay? Get the square root of this value using your calculator. Now, again, square root of 4.489799592 will give you 2.12 seconds. So, 2 decimal places na tayo. Okay? Alam nyo naman na kung paano mag-round off. So, this is the time that we're going to use para ma-solve yung problem using this equation. So, gamitin na natin tong equation. V sub x is equal to V sub ix tx. Meron na tayong value ni t. Yan yung 2.12 natin. Okay? So, d sub x, meron tayo 35.0 meters. Hindi yan negative kasi nasa horizontal component. Is equal to V sub ix natin na wala, remain at is, multiply to the 2.12 seconds natin. So, since we're after with getting the value of V sub ix, divide natin both sides by 2.12 seconds. So, cancel this one. V sub ix for our answer, divide lang natin to. Okay, for our answer, V sub ix is equal to, divide this one, will give you 16.51 meter per second. Wala tayong ika-cancel na unit kasi wala namang similar unit. So this is now our answer for this problem. Now, the initial velocity ng kinik yung ball horizontally is 16.51 meter per second. That allows it to be in this particular distance, no? Once na na-fall siya from this very high hill. Okay? So, hopefully, nasundan si Sir on how I identify the X component and the Y component. Ganun pa rin naman, Gresa ang ginamit natin. Since wala tayong value for t, sinolve muna natin yung value ni t using the time of flight equation. Equal naman yan for both horizontal and vertical component. And that's the time na we move to the next part of the solution wherein we solve the V sub ix. Okay? Yun lang yun. Now, let's have the second sample problem. A pool ball leaves a 0.60 meter high table with an initial horizontal velocity of 2.4 meter per second. Predict the time required for the pool ball to fall to the ground and the horizontal distance between the table's edge and the ball's landing location. So, sige, visualize natin. We will put it into an illustration. So, this is the table. Let's say this is 0.60 meter high. And the ball moves with a velocity of 2.4 meter per second. So, V sub ix kasi horizontal yung motion ng bola. Okay? Now, we have to identify the time, okay, required for the pool ball to fall to the ground as well as the distance, no? The horizontal distance ng bola to, on what particular distance siya na fall, okay, from the edge of the table. Yun naman yung kailangan nating ma-identify. Now, for the given, we have to look for the X component. Yan laging sinasabi ni Sir, as well as the Y component. Okay? Now, so for the X component, meron tayong V sub ix. That is your 2.4 meter per second. What else pa? Okay, lagi naman natin sinusulat yung acceleration na 0 meter per second square. Okay? Now, for the y component, meron tayong d sub y. Yan yung edge, height ng table. So, negative natin yan. Okay? And we have always acceleration for the y component na negative 9.8 meter per second squared. Okay? So, moving forward, ang hinahanap natin for the required is your d sub x and the time. Okay, now for the time, so we have to use the equation for the time of light. Hopefully, na-screenshot yung part na yon for the equation. Time of light is equal to square root of these 2 d sub y over gravity. Okay, so using the given, substitute lang natin. So, t is equal to square root of 2 multiplied to negative 0.60 meters divided by the gravity, which is negative 9.8 meter per second squared. So, multiply muna natin 2 times negative 0.60 meters will give you negative 1.2 meters. Okay, so t is equal to square root of negative 1.2 meters over negative 9.8 meter per second squared. So, cancel similar units, second squared yung natira. So, t is equal to square root of, so the answer there is, when we divide these values, 0.122448, okay, 979 seconds squared. So, square root natin, t will become, okay, as our answer, t will become 0.35 seconds. 2 decimal places tayo always. So, we're done with getting the value of t. That's the time for the pool ball to land on the ground. Okay? Now, for getting d sub x, yung equation natin dyan is d sub x. So, this is for our solution. D sub x is equal to v sub ix dx. Wala na tayong problema. We can move forward kasi may value na tayo ni t. Okay? To get the d sub x. So, given naman ang v sub ix natin. So, for our solution, d sub x is equal to 2.4 meter per second multiply to t sub x, lagi namang equal yung time of light sa whatever component yung pinag-uusapan natin, 0.35 seconds or 0.35 seconds. Multiply that, okay, cancel similar units. So, meter naman talaga ang unit for distance. Our answer for this one, d sub x is equal to, using your calculator, will give you 0.84 meters. 2 decimal places tayo always. Lagi naman natin ginagawa yun for final answer. So, this is our answer for time of light or for the time, 0.35 seconds. And for the distance in horizontal component or the x component is 0.84 meters. So, hopefully, nasusundan on how I look on the x component and the y component as well as yung paggamit ng equations and pag-substitute ng mga given moving forward for these answers. Okay? Now, let's have the last sample problem. Anton claims that he can draw a dart at a dartboard from a distance of 2.0 meters and hit the 5.0 centimeters wide bullseye if he throws the dart horizontally with a speed of 20 meter per second. He starts the throw at the same height as the top of the bullseye. Will Anton hit the bullseye? So that's the problem that we have to solve in terms of horizontally launched projectile. Now, let's illustrate the problem. So, ito si Anton. Okay. So, he believes that he can hit the bullseye if he throw the dart at 2.0 meters. So, nasa 2.0 meters siya Okay, facing the dartboard. So, yung bullseye, size niyan ay, according to the problem, 5.0 centimeters. Okay? Ayan yung dart, let's say. Okay? So, there is an initial velocity, okay, which is 20 v sub ix natin yan, 20 meter per seconds. Okay? So, identify natin ang x component as well as the y component para mabilis ang ating computation. So, a sub x natin, acceleration for the x component, lagi 0 meter per second squared. Now, for a sub y, for the y component, negative 9.8 meter per second squared. Okay? Now, v sub ix natin, given yan, that is 20 meter per second. Now, yung v sub iy natin, yan ay 0 meter per second. Okay, lagi tayo walang initial velocity for the y component. Yung v sub x natin, given naman, so 2.0 meters yan. So, what we're after is getting the d sub y. Kasi binato niya at the same height. Okay, alamin natin kung matatamaan niya yung bullseye. D sub y yun. So, we are to compute the d sub y. Okay? So, our equation for that, when you visit your screenshot for the equations to be used for horizontally launched projectile, d sub y is equal to v sub iy t sub y plus gty squared over 2. Okay? So, for our solution, we have to compute first muna yung value ng time para we can proceed here kasi wala tayong value ng time according to the given. Okay? If you analyze this. Now, dahil given ang d sub x natin at d sub ix natin, we can use the equation d sub x is equal to v sub ix dx. Okay? Pwede natin itong gamitin to compute for the time. Okay? So, bakit di po natin pwede gamitin yung time of flight, sir? Kasi wala tayong value ni d sub y. Okay, tatandaan, time of flight is computed, okay, square root of these 2, d sub y over g. Wala tayong d sub y pa na value kasi yun yung unknown. So, itong gagamitin natin since meron namang variable t. Okay, kahit t sub x yan, pwede natin gamitin yung value ng t sub x yan for whatever component. Okay, kasi equal lang naman ang time for those components. Okay, so d sub x natin is 2.0 meters is equal to v sub ix natin na 20 meter per second. Wala tayong value ni t sub x. So, leave it at is. Divide both sides by 20 meter per second. Okay, cancel this one. T sub x natin ay equal to, divide this, these values will give you 0.1 second. So, this is the time that we're going to use in order for us to proceed to this equation. So, moving on, v sub y is equal to v sub I sub y natin na 0 meter per second. May time tayo na 0.1 second plus yung g natin, yan yung a sub y mo, negative 9.8 meter per second squared multiply to square root of squared of your 0.1 second. You have to square that. Divide by. Okay? So, square muna natin itong 0.1. Wala na ito. V sub y is equal to negative 9.8 meter per second squared. What is the result of this? 0.1 square natin. The answer is 0.01 second squared. Okay? Divide by 2, multiply this one, then divide by 2. Cancel similar units muna tayo. Our answer for d sub y is negative 0.049 meters. Or, pag ni-round off natin yan, negative 0.05 meters. Since yung size ng ating bullseye ay 5.0 centimeters, how can we assure na kung natamaan ba talaga ni Anton yung bullseye? We can convert this 0.05 meters. Hindi ko na sinabi yung negative sign kasi that indicates the direction, 2 centimeter. Laging namang may in every 1 meter, there are 1,000 centimeters. So this is our conversion factor. So this is the given unit multiplied to desired unit na centimeter divide by given unit na 1 meter para makancel tong unit na to. So ang sagot natin, move lang natin yung 0. How many times? 2 times. To the right, 1, 2. So magiging 5.0 centimeters yan. Natamaan niya. Yes, ang sagot. So, Anton hit the bullseye. Okay, based on our solution. So, hopefully, you understand all the concepts involved for horizontally launched projectile. And you can proceed na to your activities for this particular topic.